Well, let's talk about the fundamental theorem of calculus and definite integrals. Okay, so we have talked about the fundamental theorem of calculus before, but it's in a different context. When I refer to the fundamental theorem of calculus, this is generally what I think of. So what you've learned before builds to this, which is truly fundamental, which is why I'm waving my hands like this, because it's so fundamental. Rock, paper, scissors. That was not the right thing. Anyway, let's begin by determining f of b minus f of a given this ridiculousness. Well, let's interpret this ridiculousness first, okay? You've seen this in a previous lesson. Capital F is defined as the integral from some c is some constant, it's an x value, to x of f of t dt. So f, capital F, is the integral of little f. So if you wanted to take some of the ideas that we've done in the past and expound on them a little bit, we'd say that the derivative of capital F, take the derivative of this side, you'd be taking the derivative of this side, and knowing what we know, this x would go down here, and we would have f of x. Okay, so I'm going to write a sentence here. We're going to take that idea and shelve it for a minute and then come back to it. If f prime is equal to f, let me use capital and lowercase. If capital F prime is equal to little f, then the derivative of capital F gives me little f, right? Right? Okay. The derivative of capital F gives me little f. Now you might be thinking, why are we using the same letter? It'll become obvious when we start filling in things in this box. It'll just sort of click down here, I believe. So if the derivative of capital F is little f, then if I want to get, I'm writing what's already on the paper, okay? You don't have to write this. If I want to get capital F, then I could integrate from some constant to x f of t dt. Okay, so in order to get from, how do I word this? Capital F, to get to little f, I'd have to integrate. In order to go backwards, I'd have to do the opposite of integration. What's the opposite of integration? Taking the derivative. Okay, I'm going to put this into slightly different words. Capital F is the, okay, we're going to hold that thought for just a second. In order to go from capital F to little f, I had to take the derivative of capital F. But if I want to go from little f to capital F, there's a lot of f's in this. If I want to go from little f to capital F, I would have to do the opposite of a derivative. I'd have to integrate. So I'm going to call it the antiderivative of little f. Okay, we're going to hold that thought. If everything is super confusing, do not panic. It's going to become clear down here in just a minute. So if all this was like, what's he writing? He wrote the same thing you already had, and I'm fleshing out some ideas, trying to articulate it. The articulation is a little clunky at times, but the main idea is going to pop up here. So using a green pen, why green? I don't know, stands out, I guess. We're going to, for fun, determine f of b minus f of a. You'll see where this is going in a moment. So first, let's figure out what f of b is. F of b would be, well, capital F would be, if I plug in a b right here, I have to plug in a b right here. So I'd have the integral from c to b of f of t dt. What's that? Well, what's f of a? Well, f of a, capital F of a, would be the integral from c to a of f of t dt. And they told us to find f of b minus f of a for reasons that will become obvious here in just a minute. So f of b minus f of a. We're going to just basically take these two things and we're going to subtract the first one minus the second one. So on this side, we're going to have f of b, capital F of b, minus capital F of a. And that's equal to all this minus all that. We'll write that all down. So the integral from c to b of f of t dt minus the integral from, c to a of f of t dt. And we'll do a little bit of mathematical magic here. So we have c to b, f of t dt, plus, I'm changing the order of these. You'll see why in just a second. The integral from a to c of f of t dt. It's one of those properties where you can turn the order around if you change the sign in the front. And I'm going to write a step that's not completely necessary. I'm running out of space a little bit, but we'll deal with it. Basically, I'm going to put this one first and then put this one second, and you'll see that c is kind of the common thing in the middle. So the integral from a to c f of t dt plus the integral from c to b f of t dt. And we have learned another property with this. If I'm going from a to c, then c to b, then basically I'm just going from a to b f of t dt. Okay, there's a whole lot of stuff going on there. It seems a little confusing. Here's what really happened. Let's ignore that for a moment. We were just using the properties of integrals, changing the order by changing the sign, and then we said, well, if I'm going from a to c and then c to b, I can just put them together and make this. I want you to see what just happened. It's about to get exciting. This is truly fundamental. And if you're not catching it, it's fine. We're going to throw it again down here and down here. So the integral from a to b of f of t dt would be, oh, let's use red. This right here is this area from a to b. That's what that is, okay? So if I want to calculate the area, I'm going to go ahead and start filling in a box. We'll use this black pen right here. If I want to figure out an area from a to b of any function, I'm going to use x here, not t, because I think it's going to just start becoming a little more practical to use the x's. So if we are going to figure out the area from a to b of any function, any function. Okay, let's pause that thought for just a second. In previous lessons, we have found the area under a curve, notice the air quotes, when the curve was a straight line, or, well, a straight line that went like sideways. That'd be a trapezoid, that'd be a rectangle, easy to find. Semicircles, things that we know. This can be for any curve. And the way to do this, because these can be x's, not just t's, is to do capital F of b minus capital F of a, and capital F is the antiderivative of little f based on all the stuff that was written here. Again, if I take the derivative of capital, I get little. If I want to go backwards, I'd do an antiderivative. Antiderivative, what's that? We'll figure it out in a few minutes.